All right, guys, so these are the 1.1 notes. We're starting with relations and functions. So a set of ordered pairs can be shown in a lot of different ways. The ways that I have here are a graph, a mapping, a table, or expressed as an equation, which is what we've seen the most. Okay. The reason ordered pairs are important is because what relations are is they're a set of input and output values. Okay, so those are our ordered pairs. The set of x values is called the domain, and the set of y values is called the range. A relation with distinct points, this is called a discrete relation. Okay, and then a relation with connected lines or curves is called a continuous relation. Okay, so identifying functions. Function is a relation in which each element of the domain is paired with exactly one element of the range. So let's use a mapping for this example. So say we have 0, 1, and 2, and these are our input values. Okay, and then let's say for our output values we have, -1, 3, and 5. Okay, so our inputs, those are our x's, our outputs, those are our y's. And then if we have a mapping and we want this to be a function, each element in the domain has to go to one of the elements in the range. Okay, so then this mapping would be a function because each x has exactly one y. Okay, something that would be not a function, okay, so let's use the same values, so 0, 1, and 2. And then for our y's, we'll use -1, 3, and 5. Okay, so then to make an example that's not a function, it says each, so that means if not all of the x's get used, that wouldn't be a function, right? So let's say 1 goes to -1, 0, we're going to take it to nothing. And then we could say 2 goes to 3, right? So then that would make something that's not a function, okay? What would also make this not a function, right, is if 2 went to a second value because it says is paired with exactly one element from the range. So the ways that this is not a function is that 0 right there is not going to anything, and then 2, we made 2 go to 2 things. So those are 2 reasons that this would not be a function. Okay? So, vertical line test. This means that x values do not repeat. Okay, so for something that is a function, we would have something that looks like this. If we draw a little graph, okay, and then we had a graph that's going through this like this. As you can see, a vertical line test, if we drew vertical lines anywhere in this graph, it would never pass the graph more than one time. Okay, and that means we would pass the vertical line test, meaning that we have a function, versus something that doesn't pass the vertical line test would look like this. Okay, then you can see if we draw a line vertically through this, it passes at 2 spots, right? It passes here and there. Okay, so that would be something that does not pass the vertical line test. All right, so this next section says find the domain and range of each relation. Then determine if the relation is a function. If it is a function, state whether it is one-to-one. What does one-to-one mean? It means that each x has a unique y value. Okay? So I'll explain what that means in a little bit more depth when we do a problem. The other thing, that in order for something to be one-to-one, it already has to be a function. So it must be a function. If it's not a function, it definitely cannot be one-to-one. Okay, so we only are answering the one-to-one question if we say yes to it being a function. So, things that make a function, right? Each value of the domain has a value that it has exactly one value in the range. So we have -1, 0, 4, and 6, so no x values repeat. We have -9, -5, 3, and -2. So because no x values repeat, all the x values are getting used. This is a function. Okay, and then the question of is it one-to-one is every y value different? Okay, does each x have a different y value that it goes to? We have -9, -5, 3, and -2. So then we could say, yes, this is 1-to-1. Okay, when we're writing the domain, when it's points like this, okay, this would be discrete because it's just a bunch of random points. We would use a curly bracket, okay, and we would say all of the x values for the domain. So -1, 0, 4, and 6. Close the curly brackets. For the range, we would do the same thing, except we're talking about the y values, okay? So we'd have -9, -5, 3, and -2. All right? So then I would want you guys to try out that next one. Try to decide, is it a function, yes or no? If it is a function, is it one-to-one? Write the domain, write the range, okay? For values that repeat, if that would ever happen, you only need to write it once. So looking at this one, right, 5 and 5 is going to repeat, okay? So because it repeats when we're writing our domain, we would only need to write 5 one time, okay? So let's take a look at number 3. Number 3, this is our table, okay? So then let's talk domain and range. Domain would be 7, 2, 0, and -4. The range is going to be -8, 3, -1, 3. And then we need to determine, is this a function? So all of the x values have a y value. That's the first check. And then the second check is, do any x values repeat? No x values repeat, so yes, this is a function. Then we need to decide, is it one-to-one? When we ask, is it one-to-one, we need to decide, do any of the y values then get repeated? And in this case, we have 3 gets repeated, so it's not 1-to-1, okay? So again, you guys try out number 4, write the domain, write the range, and then determine if it's a function. All right, number 5. So again, this is still discrete. We're just mapping an x value to a y value, okay? So this is still curly brackets. So if we're doing curly brackets, we're going -4, -2, and 5 for the domain. For the range, we have 0, 3, 7, and 9, okay? In this question, all of the x values get used. That's our first check. The second check is, do any x values repeat themselves? And it looks like right there, 5 does repeat itself. So this is not a function, okay? Just say no. All right, let's keep going. So this is our first example of a continuous function. Continuous functions, we write the domains in our interval notation. So continuous, the domains is the x values, the furthest from the left to the furthest from the right. And as you can see, both of these things are closed circles. So then because they're closed circles, that means they're included. So we go -1, 2, 3, 4, 5. That's our lower bound for our x values. +1, 2, 3 is our upper bound, and it's also included. So that would be the domain. It goes from -5 to 3 on the x's. Range would be the same idea, right? What's the lowest range is -1. So we go -1, and then the highest range is going to be 1, 2, 3, 4, 5, 6, 7. So -1 to 7. Okay. When we have a graph like this, easiest way to tell if it's a function, vertical line test. So we draw a vertical line straight through this graph, and as you can see, we pass through 2 points. So then this is not a function. Okay? You guys try out number 8 and see how you do. Okay, we'll keep going. So number 9 here. Number 9 is asking what is the domain and range and the function, of course, like the questions we've been doing. Okay, so domain here, the furthest to the left, 1, 2, 3, 4, 5. So we're going -5, 1, 2, 3, +3 again. negative 1, 2, because that's the lowest point, so negative 2, all the way up to the highest point, 1, 2, 3, 4, 5, which is positive 5. So that would be the domain and range. Is this a function? So if we're looking vertical line test, it doesn't look like we could draw a vertical line through any point of that and cross it twice. So then we would say, yes, this is a function. Now we need to decide, is it one-to-one? So this one is kind of a unique matter. Okay, we actually could have talked about this in number 8. But determining one-to-one, in this case, the horizontal line test is the best way. Because if you can draw a horizontal line, that means y values are getting repeated. So because y values are getting repeated, this is not one-to-one. Okay? Same idea in this last question. You might not have gotten this part, but look, if you draw a horizontal line right through here, you get y values that repeat, so then you would say it's not one-to-one. Okay? So horizontal line test, awesome way to determine if something is one-to-one or not. Number 10, okay, these are all discrete points. So in this case, we need to know all the x and y values. Okay, so this is negative 1, 2, 3, so that's negative 3, positive 1. That's negative 3, negative 2. This one is 0, 1, 2, 3, 4. This one is positive 2, negative 1. And then this one's 1, 2, 3, 4. 1, 2, 3, 4, 5. So positive 4, negative 5. Okay, so then when we write the domain, it's going to be the curly brackets. Doesn't matter the order. So negative 3, 0, 2, 4. Domain is going to be negative 5, negative 2, negative 1, 1, and 4. Is this a function? Not a function because the negative 3 repeats. Okay. So I hope we're doing okay with this stuff, guys. We're almost done here, so just a couple more to go. So these are getting into our things that are a little bit more like graphs. These are the things that are getting a little bit more into graphs. So in this case, we have something that is continuous, and then it's going on forever. So in the x direction, we'll be going to the left forever and the right forever. Okay, so the domain in this case is a special one where we say it goes from negative infinity to positive infinity, which we could also call all real numbers. Okay, the range is the same idea. So the range is going down forever and it's going up forever. So we could say negative infinity to positive infinity, or you could also just say all real numbers. Okay, sometimes functions that go forever are tougher to figure out if they will pass the horizontal line test, but as you can see, this one does. Okay, so yes, is a function, and then we draw the horizontal line in here, and the horizontal line test does not pass the test, so then we say it's not one-to-one. Okay, so hopefully you guys are starting to get an understanding of all of this going on. And as always, you can ask questions when you get back to class, okay? So we're just going to go through these last couple. I'm going to do, I think you guys can, actually we'll talk about 13, yeah. So 13, negative 1, if we're looking at the domain, it starts at this point and then goes forever to the right. So negative 1, 2, 3, 4, 5 would be the starting point. And then the ending point, it doesn't have one, so it's going to go into positive infinity. Same idea with the range, right? The starting point right there is at negative 2, and then it's going to go on forever in an upward direction, so then the range is going to positive infinity. Is this a function? Yes, would pass the vertical line test. Is it one-to-one? Yes, okay. It's also one-to-one because it would pass the horizontal line test as well. Okay, so those are the things you need to be looking for when you're doing these questions. These last couple, these would be ones that you're trying to graph, okay? So let's just go through them real quick. If you need to sketch it, that's totally fine, right? Negative 1, and then it's going down 5 to the right 1. So 1, 2, 3, 4, 5. To the right 1 would be here. So this graph looks like this. Domain in this case, right, it's going forever in the x direction. So we could say all real numbers. Okay, you could also say from negative infinity to positive infinity. Both of those are good. The range also would be all real numbers. And then is this a function? Yes, it is. okay? And then 1 to 1, it would pass the horizontal line test everywhere, so it is 1 to 1. Okay, the ones that are a little bit tougher is going to be this question right here. There's only one on the homework that looks like this, but just for reference, okay? This positive 3 tells me where we're crossing the y. Okay, so we're crossing the y at positive 3. And then an x squared graph, if you don't remember, looks like a u. Okay, so because it's positive, it's opening up. And so then we can write the domain and range. It's going to go to the left and right forever, so all real numbers. Range, it's going to start at positive 3 and then go up forever. So 3 to infinity. And then is this a function? Yes. Right? The one thing that this thing doesn't do, though, is it does not pass the horizontal line test. So it's not 1 to 1. Okay? Awesome. I think that will be enough for you guys to get through the homework today. So try 17 and 18 to finish these notes off, and 14 and 12 because we didn't do those. So try all those ones to get them finished, and then also try out the homework. Okay, as always, if you have questions, guys, just ask me when you get back to school.